Welcome to Plugged In, a podcast by Okefenokee OREMC about our co-op, our community, and our shared connections. I'm Michelle Hutchins, your Director of Marketing and Communications, and joining me today is Al Sandrick from the National Weather Service. Welcome, Al.
Thank you, Michelle.
Thank you for being here. It's been a couple years since we last got together when you came up and helped OREMC with a hurricane preparedness tabletop exercise.
Yes, ma'am. It's a pleasure to be with you again.
Well, we're glad to have you. Al is pretty much the Southeast's weather expert, emergency management expert. He is the warning coordination meteorologist with the National Weather Service out of Jacksonville. You're an alum of the National Hurricane Center. You're a veteran. You're a veteran. You've served in the Marines, and you do a great deal of emergency management training and development. And today we're going to talk about the predictions and forecasts and conditions related to the 2024 hurricane season. But what else what did I leave out about you?
Well, let me give you a quick correction. I actually served in the Navy, but I served with the Marines in Beirut as a sailor.
My apologies.
People don't realize how many sailors actually go ashore with the Marines. I would say for about every Marine, about every 4 or 5 Marines on shore, there's one sailor that deploys with them.
Okay. Did not know.
Yeah. People think it's just corpsmen, but it's not.
But nonetheless, you are a weather expert. Talk to us a little bit about your background and why I've asked you to come speak to us today.
Sure. So I did start in the military as a military meteorologist, and that was as an enlisted meteorologist. And I really enjoyed it. So I got out and went to Florida State University. I got my degree in meteorology from there, particularly in tropical meteorology. With the skills that I had picked up when I was in the Navy with oceanography and satellite meteorology, I was picked up by the National Hurricane Center to work there. I worked in a branch that was the satellite branch, so I would actually give an estimate of the intensity of the storms to the hurricane specialist. And then when there was a storm like Hurricane Andrew, I actually assisted the hurricane specialist and Dr. Bob Sheets, and I did a lot of the media. So if you listen to the radio during Hurricane Andrew, you heard me.
Well, the reason I asked you to come talk to us today was the media since April has really been talking about the predictions relative to this hurricane season, and that there's a higher number of level of storms predicted, a higher than normal level of actual named major hurricanes predicted, and a lot of discussion around the changing conditions that's feeding all this. And so that's kind of where I want to sort of start our conversation is why all this chatter?
Sure. So, we like to talk about media hype, and everybody thinks that everybody wants to scare everybody out there. This year, it's really, really well-grounded. A lot of my friends, like Dr. Phil Klotzbach out in the Colorado State University, and some of the folks who are the climate specialists and hurricane specialists down in the Hurricane Center, we've all been looking at this building over the course of the last year. So what are we seeing? We're having conditions in the Central Pacific settle down towards either neutral or La Nina conditions. And what that does is that reduces the wind shear in the Atlantic Ocean. Sounds kind of crazy. Why would we be concerned about what goes on in the Pacific Ocean? Well, when we have El Nino conditions, the waters are warm, and we get these absolutely huge thunderstorms that build up. We've all seen them build up over the swamp, and you see that outflow that goes out the top of the thunderstorms. Well, these huge thunderstorms that develop in the Pacific Ocean, that outflow actually goes up toward the equator and then goes across it and then east across the Caribbean Sea. So when we have El Nino conditions, the wind shear that's coming from the Pacific Ocean is going in the opposite direction of the storms that are coming off of Africa.
Okay.
So that tends to rip them apart. When we get neutral conditions, well, there's not really much wind shear at all. And when we get La Nina conditions, now the winds in the Atlantic Ocean are coming from Africa towards Central America, moving the same direction as the tropical waves that are coming off of Africa. So there's really, not only is there not wind shear, but it also enhances it because it allows the thunderstorms to build up straight up and down. So let's think about a chimney. If we've got a chimney and it's straight up and down, it's going to be very efficient. If the chimney is tilted, it's not going to be nearly as efficient in getting the smoke away from the fire and allowing the fire to burn. So straight up and down thunderstorms inside the tropical system allows it to develop. So that's the first thing that we're looking at. The second thing is the water temperatures. And there are two ways of looking at this. We can look at the sea surface temperature, which is sort of like a skin temperature. It goes down about 6 inches or so into the water column. Think about that as like an X-ray. So when we look at these sea surface temperatures or seeing the very, very top of the water, it's like a doctor looking at an X-ray. We have another way of measuring the water, and we use certain satellites for that, and it's called ocean heat content. And we also call it tropical cyclone heat potential. It goes by two names. Well, tropical cyclone heat potential should tell you, again, how we use it. It gives us a measure of the energy that's available in the water. I can tell you right now, the tropical cyclone heat potential, even off of coastal Georgia, is through the roof.
Because the waters are warmer than normal.
Extremely warm. And not only are they extremely warm at the surface, they're extremely warm going down in depth. So let's think about this as tanks of gasoline. The deeper the warm water goes in the water column, the more energy that's available. So let's say you take your car to a gas station. You fill it up. You park it in a parking spot. You let the engine keep running until the gas tank goes down. You turn around, you go back, you fill it up again. You go park it again. You let it run down. I don't know why you would do this, but it's a good example. You keep doing that over and over and over again. Well, with deep, warm water, that's exactly what the hurricane can do. It can sit in one particular location and just upwell or bring more warm water up to the top for it to feed off of. Dorian did that in 2019. If you had told me in 2018 or 2017 that a Category 5 hurricane would sit over the shallow waters of the northern Bahamas Islands, the Abaco Islands and Grand Bahama Island, and maintain Category 5 status for 24 hours, I'd have told you were nuts. But yet we saw it. And what it was doing was it was bringing deep, warm water from the waters around it and pulling it into the Bahama Islands and feeding off of it. So, it's just incredible what the ocean temperatures are now. Another factor is the sea level pressures across the area. We've got lows.
What do you mean by that?
Yeah, well, we measure, you live at the bottom of an ocean of air. So all of this air is pushing down on you. And we have high pressure and we have low pressure, right? Mm-hmm. High pressure when you're up north, say up in New York or New Jersey or that. And in the wintertime, high pressure comes over you. It gets very, very cold, right? Low pressure tends to be warmer. Well, what we have is we have low pressure across the Atlantic Ocean, east of the Caribbean Sea, and across the Caribbean Sea. And then we have high pressure to the north of that. And that's what's causing that big heat wave that we're getting up in the northeast right now.
Okay.
So that does two things. The lower pressure across the Caribbean Sea and the Atlantic Ocean, the tropical Atlantic Ocean, allows the storms that are coming off of Africa to further develop because they've got a head start in that lower pressure area. The high pressure area to the north stops them from going out into the Atlantic Ocean. So there's a good chance that a lot of the storms this year will be coming west towards the Gulf of Mexico and towards the continental United States.
Okay, so let me clarify what I just heard.
Okay.
So we do predict a higher level of storms. And then when I think about last year, is all the storms, they kind of came off and they stayed way out in the middle of the Atlantic Ocean and then curved northwest. I mean, almost all of them did that.
Other than Idalia.
Because of, I guess, the wind shear from El Nino and, some of the other conditions you've been discussing. So what I heard you say is most of the storms are going to come across up toward the Gulf versus coming up the Atlantic?
That's been the pattern so far this year.
Well, there's 3 of them out there right now, and that's what they've all kind of been doing thus
exactly.
far.
Now, there's a difference between a weaker system and a stronger system because the weaker system tends to get pushed around by the high pressure that's to the north and what we call the steering currents.
Okay.
The stronger system can actually kind of bully its way through. So it tends to kind of force its way through high pressure systems. So some of the strong hurricanes may actually recurve up into the Atlantic Ocean. But with the pattern we see right now, there's probably a better chance that we're going to see these systems coming into the Western Caribbean, the Gulf of Mexico, and towards the Eastern Seaboard. It's probably the pattern, at least early this year. Patterns do change.
So I remember from when we had our tabletop a couple of years ago, one of the things that you sort of reinforced, which was told to me by one of my colleagues early on in my tenure here at Okefenokee OREMC, is that actually for concern over our distribution system, our electric distribution system, storms that come from the Gulf tend to do much more damage on our area, on our system, than one that comes straight up the eastern seaboard.
Sure. So let's talk about two different things. Let's talk about the two different vulnerabilities here. A storm like Idalia coming in off of the Gulf of Mexico.
And that was the one from late August last year, August 30th.
Yes, ma'am. So a storm like that, we look for two things when a storm is making landfall. How strong is it as it approaches the Gulf Coast, Appalachia Bay, the Nature Coast in Florida, and how fast is it moving? The combination between the two will give us an idea of how much winds are going to be brought inland across the Okefenokee area, across Charlton County, Brantley County, Ware County. And that was one of the concerns with Idalia. Idalia was going to make landfall as a major hurricane, at least Category 3, and was moving at a relatively fast speed. So we were prepared for major winds to come across the area. Idalia was a little bit unusual in that it collapsed at landfall. It went through a eyewall replacement cycle, which is an internal structure of the hurricane, and basically we saw the entire southeast side of the storm collapse. In fact, so much of it collapsed, it was very hard for us to get an idea of what the winds were as it was moving across Suwannee County, Florida, Hamilton County, Florida. And we did see the wind shift to the northwest quadrant of the storm. Very, very unusual. Now, in 1896, we had a storm that made landfall just north of Cedar Key. And it was racing ahead at about 35 miles per hour ahead of a very, very strong cold front. And that storm just absolutely ravaged the Okefenokee OREMC. I hope I got that right.
Yes, you did. OREMC.
Because all of these regional ones have slightly different initials.
And that was all before it even existed. So
right. But that entire area, that's now your service area, was absolutely, totally devastated. Hoboken, Nahunta, Rayburn, Toledo. At that time, Toledo down in Charlton County was actually known as Toledo Blade, and it was a camp for loggers. Oh. There was a steam shovel that was out in the swamp that was part of that project to dig the canal from the St. Mary's River to the Suwannee River, and it was blown over. Darien, Georgia, they said after the storm went through, looked like Sherman's bummers had come through the town.
Oh, my.
So it was devastated. The windmill at Jekyll Island was destroyed. So that's what the winds alone did associated with that 1896 hurricane. And it very much was like Michael. So everything that Michael did in Mexico City Beach, in Marianna, Florida, in Albany, Georgia, and then up towards Fitzgerald, and I'm trying to think of some of the other communities, Asilla, I believe, East Point. Some of the towns escape me. But that devastation that occurred just west of the Coffee County and Hazelhurst area, Jeff Davis counties.
Yep.
Okay, all of that was translated further to the east in 1896. So Michael was the 1896 hurricane. So that shows you what can happen from a storm coming in off of the Gulf of Mexico. But we do need that combination of strong landfall and fast forward motion to do that. Most storms do weaken as they come across. But even a Category 2 hurricane making landfall, say, near Cedar Key and moving north across this area, we could expect at least strong tropical storm force winds across the inland areas. Now, let's flip that and let's look at the 1898 hurricane, which came in from the Atlantic Ocean. Now we've got the complete deal associated with that storm. Now we have the Category 3, Category 4 winds in the inner core of the hurricane coming across parts of Camden, Glen, Brantley counties. And at the same time, we had the absolute tremendous storm surge coming in off of the Atlantic Ocean.
And this was what year?
1898.
1898.
And why are we talking about storms that far back? Well, we've been extremely lucky in the 20th century and 21st century so far here in coastal Georgia. But, the folks who say coastal Georgia doesn't get hit by hurricanes, if you were to speak to somebody from the 19th century, from Darien or Brunswick or St. Simon's Island or even up into Savannah and St. Catherine's Island, a little bit further to the north of us, they would look at you like you were totally nuts.
Huh.
They got hit by a major hurricane in 1804 that drowned 500 people in coastal Georgia. There was a major hurricane that came across the St. Mary's River entrance. We've got 3 eye reports from that one. In 1813, that destroyed the fleet that was based there to fight the British in the War of 1812. Destroyed Mulberry Grove Plantation on St. Simon's Island. 1824, we got hit by a storm that was probably a Category 3. 1854 was a Category 3 hurricane. 1881, a Category 2 hurricane drowned about 700 people in the vicinity of Savannah. In 1893, we had a Category 3 hurricane, but an absolutely huge size hurricane in Winfield that drowned between 1,500 and 2,500 people from about the Altamaha River all the way north into Charleston.
So the bottom line is, and it's not meant to be a scare tactic, it's just meant to be a reality check. If the conditions are right, and from what you're saying, conditions are more right this year than maybe they have been in a very long time, that the potential exists for a storm along the lines of some of those that have indeed significantly impacted this area in the past.
And let me tell you, one of the things I've been telling all of the emergency managers that's very, very concerning to me, I don't want to say frightening, but very concerning, and that is when we look at the peak of the Atlantic Ocean hurricane season, the Cape Verde hurricane season, the storms that come all the way from Africa.
Which is when?
That's about September 21st.
Okay.
Well, we all know the range of tides that we have here in coastal Georgia. And during high spring tides, we can get tides that are up to about 9 feet above mean low water as that comes in. Well, that secondary peak tide of the year, so that the second highest series of tides for the entire year correspond perfectly with the peak of the Cape Verde hurricane season.
I gotcha.
The highest tides of the year in October, in the period from about the 16th to the 19th, coincide absolutely perfectly with the peak of the Northwest Caribbean Sea hurricane season, which have a tendency to go into the Gulf of Mexico and come across the western Florida Peninsula and up in our general direction. So basically the two peaks, there's a primary peak and a secondary peak for the entire basin. Mm-hmm. One is for the storms in the Atlantic Ocean that come from Africa. One is from the storms in the Northwest Caribbean Sea. Both of those peaks correspond with our peak highest tides of the year.
Interesting.
And it would not take a direct hit during that period of time to cause substantial problems, at least along the lines of Irma and Matthew.
Because of flooding.
Greater, because of the flooding. Because with the astronomical tide, we have a major head start. So should the storm make landfall at dead high tide, we already have 3 feet above normal water just because of the moon pulling at us for that spring tide situation. And then on top of that, if we've got a nor'easter ahead of the hurricane, which we normally do, that's a very common pattern for us.
Why? Why is that a common pattern?
Well, in order to get a hurricane in here, it's got to be blocked from recurving into the Atlantic Ocean. So that usually takes strong high pressure to the north of us, and that's exactly what a nor'easter is. It's the winds around the southern part of the high pressure system blowing in off of the Atlantic Ocean. It brings all that moisture in, but it also pushes the Atlantic Ocean into our estuary system. So we'll get those high tides associated with it, and then boom, we get the flooding that occurred. And that is exactly what happened in Irma. Most of those winds that we experienced in the early part of Irma were the nor'easter, and the tightening between Irma and the high pressure to the north of us just squeezed the air and made the winds grow stronger and stronger. And eventually, even before Irma's wind field came completely into this area, we were experiencing hurricane force wind gust on St. Simon's Island and Jekyll Island. Mm-hmm. And that was before the storm even came in. So all that water is being pushed ahead of the storm into coastal Georgia. We're a big catcher's mitt for
Right.
storm surge.
For storm surge,
Yeah.
yes. So I'm going to kind of go back to what you were saying at the beginning of all this, is that among the things, warmer temperatures, a La Nina versus a El Nino, which those are very cyclical. They are naturally occurring cycles. Then we are just coming off an El Nino, correct?
Yes.
It's been in play for about, 2-3 years?
About 2 years.
2 years. And so you said that right now it's like, is it going to be neutral or is it going to favor La Nina conditions, warmer sea temperatures, so on. But the other issue is this high pressure over the Northeast. And so because of that high pressure, that's what keeps them from going back out, which is largely what happened a great deal last hurricane season.
Yes, ma'am.
But because of that, you're saying they should generally be pushed to the Gulf, but they could come straight up the eastern seaboard as well.
Definitely could.
Okay,
Now,
so I misunderstood you earlier. I thought it was more of that everything was going to be pushed more toward the Gulf, but it could be an either or. But it does still sound like you're saying there's greater potential for them to go to the Gulf and develop.
Yes, ma'am.
Just because of the conditions in play.
Right. So let's talk about larger scale features and smaller scale features. So we have features that set up for weeks to months at a time. And that's that Bermuda Azores high pressure system. Mm-hmm. And right now it's very, very strong. Again, hence the heat wave that we're seeing across the Northeast and the Great Lakes states. So those tend to be the overriding pattern. However, you can get features that come in for a short period of time, 3, 5, 7 days, that come in and push that pattern out of its way. And that could be just the right window for a storm to recurve and go on off into the Atlantic Ocean to the east of us. Mm-hmm. So there certainly will be recurvers. There's no doubt about that. That's always going to happen. When we look at the big hurricane seasons that are what we would call analog years for this year, so a lot of times we look at the patterns and we say, okay, when do we see this pattern before? It says history, may not always repeat, but it definitely rhymes.
Okay.
So as Mark Twain said, well, we can kind of look at the patterns and say, okay, what years have we seen this type of thing? Well, one year that we saw this type of thing was 1893. And in 1893, we got hit by 2 hurricanes here in coastal Georgia, both of which were majors, by the way. And a lot of storms did recurve in that year up into the Atlantic Ocean. But enough storms struck the continental United States for 1893 to be one of the major historic hurricane seasons. Another year that we see a similar pattern was 1933. Well, guess what? 1933 was a major year for landfalls in the United States and the Caribbean, across Cuba. So some of the strongest hurricanes that we saw occurred in that year, and Virginia was hit by a major hurricane in 1933. So, basically when we look at analog years, the larger scale pattern that we're seeing kind of tells us that most of the stuff should come further to the west. And we're already seeing that with the tropical waves. There will certainly be recurvers that will go out into the Atlantic Ocean.
So one of the other things that we hear, again, in media about hurricanes, or that gets talked about, is stronger storms. The storms are getting stronger. Is that true or false?
So there's anecdotal evidence, and then there's the actual scientific evidence, and this has been debated very, very seriously in the scientific journals. I will tell you that one of the things that we are seeing, and this nobody argues about, is rapid intensification. We are seeing more rapid intensification of hurricanes strengthening very, very quickly in a short period of time than we've ever seen in the historical record. Now,
Idalia was one of those.
Idalia was one of those. Michael was one of those. Ian was one of those. Charlie in 2004 was one of those. We saw Umberto over by Texas that went from a tropical disturbance to Category 2 hurricane inside of 24 hours.
Wow.
The real record for this one was the Hurricane Otis out in the Pacific Ocean that just hit Acapulco, which went from a tropical disturbance to a Category 5 hurricane within 24 hours. And, now this is not just sea surface temperatures. This is not just ocean heat content that did this. There was something else internal to that hurricane that we don't quite understand. And believe me, Otis will be studied very, very heavily. But again, Hurricane Michael, if you told me a Category 5 hurricane was going to hit that area near Panama City, I'd have told you were nuts, because the water's relatively shallow off of that area. And it's very, very difficult to support Category 5 status all the way into that area. But yet Michael was able to do that. And, we had Hurricane Hugo, which made landfall over near Charleston. And that thing was intensifying all the way into landfall in 1989. But in 1989, that was kind of the exception. Now these rapidly intensifying hurricanes all the way into the coastline, I'm not going to say they've become the rule, but they've become much more commonplace. And the fact that I could just rattle them off the top of my tongue.
Yeah.
And one of the things we have noticed is of the Category 5 hurricanes that have hit the United States, most of them were tropical storms 72 hours before they made landfall.
72 hours.
So think about that.
Wow.
That's a special needs evacuation time frame for emergency management. That's cutting it close.
That is cutting it close. Very close. Well, it's funny. I remember it was my birthday. I was down at my dad's 3.5 hours south here in Melbourne last year when Idalia started to gain momentum. And so I remember sitting there, posting my first kind of warning about Idalia, tropical storm. We're preparing, we're moving forward. To be mindful, we're going to stay on top of it. And, I think it was 24 hours later, it was a Cat 4, and then it impacted our service area on Wednesday the 30th. And I did a video stand-up because, at some point you need to not just post words, you need to kind of help people really understand. And, all indications were that this was going to have a significant impact on our service area. And I wanted people to be prepared that you're going to be without power. It could be a multi-day event. And the interesting thing was there was some feedback that it's always interesting what people hear. Because some of our colleagues were in the grocery store and they said, yeah, OREMC says we're going to be without power until next Tuesday. Well, I never said until next Tuesday. I did indicate it could be multi-day and to be prepared and to be ready for that. Fortunately for us, we responded to our damage and were able to restore all power in 48 hours. Right. We were lucky. Many of our sister co-ops and other folks west of our service area were out for a week or more. But the purpose of sharing information like this is to give folks a reality check. You don't know, you never know for sure, but it's better to understand that potential does exist. And yeah, we may be the westernmost point on the eastern seaboard, and everyone thinks that, as you said, that catcher's mitt kind of protects us, but it can also be the bullseye.
It is your best friend until it is not. And then it becomes your worst enemy.
So we talked about the strength of storms and the debate whether they're stronger, and you've indicated that definitely there's a demonstrated rapid intensification. We'll talk about size. That's the other thing we hear about, is that storms are getting bigger, that they're encompassing greater square miles than they used to. Is that true or false?
Again, anecdotally, it seems that way. I don't know that we could ever really totally go back and really, really see, because hurricanes do go through cycles.
Sure.
So we talk about the late 19th century a lot, because the late 19th century, hurricanes just went absolutely nuts.
It was obviously very active.
Extremely active period of time, and very much like what we're going through today. But what did we not have in the late 19th century? We didn't have satellite imagery.
Right.
So today we can look at the satellite imagery and we can see the size of a Dorian. We could see the size of a Michael. We could see the size of an Idalia. Well, there's no way we could ever go back and actually look at a satellite picture of the 1893 hurricane when it made landfall near Savannah. Now, we do know it was a very large hurricane because we can kind of go into the history books and we can get reports up and down the coastline and see how big the wind field was. Dora, 1964, was another very, very big hurricane with broad wind fields. So it does seem like they're getting larger, but I don't know that we can actually say that, especially not scientifically. That would be very difficult.
And that was one of my questions for you is, bigger, stronger, or is it simply that we just know more because the instrumentation and technology gives us so much more information, and generally, despite some of the very rapid intensification, more information, more warning ahead of time.
Exactly. And in fact, we're expanding the wind field information that we give out to emergency managers to a longer time frame. So we used to only put wind speed information into our forecast out through 72 hours. Well, now we're getting so much better, we're able to put it out at 96 and 120 hours. Is it going to be absolutely perfect? No. But it's going to be very good, and it's going to be very helpful to emergency managers. So we've got satellites. We've got aircraft. Every time you fly in an airplane, you are part of a weather observation network because that plane is sending information back that goes into our computers. The ships that are out there, when you go on a cruise ship, those cruise ships are part of the voluntary observation network or program, and they are actually sending information back that go into our computers. We have our weather balloons that we launch twice a day here in the United States, once a day down in the Caribbean Sea. That information goes into there. Satellite information goes into there. Sea surface temperatures go into it. Ocean heat content goes into it.
So much.
When I started in meteorology in 1982, we had what we called the primitive models. And they were primitive. They just basically looked at the atmosphere and threw a couple of equations into it and said, okay, we're going to do. Today, the calculations that these supercomputers are doing into our computer models just staggers my imagination, because over the course of my 40-year career, it's been just absolutely incredible, the things that have changed with observation networks, computing. So we're much, much better in producing the forecast and getting the word out. Now, there's always going to be those things that we're not going to be able to foresee, like the collapse of Idalia before it made landfall. And here is kind of the problem. Folks in your area of responsibility, your AOR, they got lucky. And I don't know that they realize how lucky they got. I am a person, I pride myself in trying to keep the forecast down to real. I don't like getting into, the cone of uncertainty says the storm can travel to the west. Well, if the model data is not telling me that the storm is going to travel to the west, I try to stay away from those scenarios. Right?
Yes, the cone of concern has definitely become quite prevalent in our modern day vernacular over the last couple of years.
It has, but it's a statistical tool.
Yes.
Right? It's based on the National
spaghetti
Hurricane
models.
Yes. It was based on the National Hurricane Center's average error. So when I see that the National Hurricane Center forecast is not really moving in 4 to 6 forecast cycles, and all the computer models are either on top of the NHC forecast or to the east of the NHC forecast, I'm not going to talk to the emergency managers in coastal Georgia and say, guys, the cone of uncertainty still says the storm can come to the west, when all the information is telling me it's either going to stay offshore or go to the east.
Gotcha.
Okay. During Idalia, I did things that I never dreamt I would do. I called the emergency managers in at about 5 o'clock in the morning in the Swanee Valley, and I was about to go up into southeastern Georgia, but I started with the Swanee Valley. And I said, guys, I need to talk to your dispatchers. I want to speak to you, your fire chief, your chief law enforcement officer, and your dispatch supervisors. And it was like, this is what's going to happen as this storm makes landfall. This is what I need you guys to be prepared for. Mm-hmm. This is what I need your dispatchers to tell your people if buildings start collapsing around them. Okay, that's how seriously we were taking Idalia as Idalia was making landfall.
Well, it was a 4.
I have never done that in a 40-year meteorological career. The fact that the storm collapsed at landfall, again, totally unforeseen and
gratefully
very lucky for us.
Yeah.
Folks, take it for what it is. You got lucky in Idalia. And the problem is when we get lucky a bunch of times, and a hurricane in any one particular location is really, it's an extreme event.
Sure.
But the people of Madison County, Florida, The people of Valdosta, they didn't get lucky in Idalia.
No.
The winds actually shifted over them, which is, again, a very unusual situation.
Well, my daughter is a student at Valdosta State, and she was in Valdosta when it came over.
But I was getting the people of Swanee Valley ready, at least the emergency services and the dispatchers ready for structures collapsing inside of Live Oak, inside of O'Brien, and some of the communities along the Swanee River. And thank God we didn't get there.
Yeah.
We got lucky. Take it for what it was.
Check out part 2 of Beyond the Headlines, the 2024 hurricane season, to hear more from Al Sandrick on how to prepare for hurricane season.